Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have count of subarrays with score less than k. So on that problem statement, they have given the score of an array is defined as the product of its sum and its digit, and its products of its sums and its length. Sorry, the product of its sum and its length. So here you can see on this example. So if this is the array is given to us, then the score of the array is the sum of every elements multiply the length of the array, multiply by length of the array. So they have given a positive integer array. So please take a note of this. Positive integer array nums and an integer k. Return the number of non-empty subarrays of nums whose score is strictly less than k. So we have to tell out how many number of subarrays here exist where the score of the subarrays is strictly less than k. I think the problem statement is very straightforward. A subarray is a contiguous sequence of the elements within an array, that we all know. So on this example test case you can see, so the nums is given to us and k is given to us as a 10, and the 6 subarrays having scored less than 10 are 2 as a single, 1 as a single, 4 as a single, 3 as a single, 5 is a single, 2 and 1 is a couple with score equals to 2 plus 1 into 2, which is also less than 10. Note that the subarrays such as 1, 4, 4, 3, 5 are not considered because their scores are 10, 35 respective, 36 respectively, while we need to scores strictly less than 10. So that's the reasons we can't consider them. On this example test case, you can put your formula and like same way you can try to build, you will get 5 subarrays of length satisfying the conditions less than equals to k, the score. And the nums is given as 10 raised to the power 5, and every element is in the range of 10 raised to the power 5 at max, and k can grow as big as 10 raised to the power 50. Yes, although the problem is tagged as an hard difficulty, but I don't think so. Like it is kind of a like very naive sliding window problems, which currently as a should definitely tagged as a medium. It's not an hard problems for sure. So yeah, now quickly go to our OneNote to discuss more on that. I think if you are solving, if you have already watched our video of sliding window playlist, like at least 3 videos of our sliding window, then this question is kind of a cakewalk. Like the same things, the same intuitions building things we are discussing from very last sliding window questions altogether. So the same template I have used. I have not changed a single line on that template. I have used exactly the same template. So yeah, but for sake of simplicity, which is coming to this video as first view, so for them, like I will give a high level overview for this current problem perspective. But on template perspective, if you not able to understand at any part, please go to the sliding window playlist and please watch at least first 3 videos of this to get the entire gist. Or more specifically, I will suggest you please go to the first 3 videos, then try this problem to your own, and if you are not able to solve the problem, then only jump on the video explanations of this current problem, and I am like 100% sure you will solve that problems on your own after completing that sliding window playlist video we have it. Yeah, so now discuss on the current problem. So what they have given to us. So if I consider this as an array, am I able to write it? Yes. So let's suppose this is our array A, B, C, D, E, F. So if I am an arbitrary point, let's suppose my right pointer is this point. So I have to know, I have to know which all lefts. So my left pointer can be at here, my left pointer can be at here, my left pointer can be at here, my left pointer can be at here. So we will start our right pointer. We will start our right pointer in on the same way. I am going to write the pseudocode so that we will not miss anything. So you will get the intuitions building part. You will also get the pseudocode digest to your brain also on the same go. So here for sure run the forward loops of the right pointer loops to n times. That we will definitely do. And for that we will start our left pointer at some point at 0th index at this index. So let's suppose whatever the current L, let's suppose L is standing at this particular point and our right is pointing to this particular index. Which index? This particular index. Our right is pointing to this particular index, right? So we are then considering this particular window block. We are considering this particular window block. So how we can then calculate our score? How we can calculate our score? So our score is nothing but maybe we are carrying a running sum. So our running sum should be this. If we are standing at this particular index, our running sum is already going to be updated to sum of all those. Sum of all those is already stored at running sum. So we already have a running sum where our left is pointing from our left to right. We already have our running sum. And what is the size of it? What is the size of it? The size of it is nothing but r minus L plus 1. Very intuitively we can say r minus L plus 1. We are solving this size things almost like last 4 to 5 videos. So it is the size of this particular window is nothing but r, where r pointer is, if L pointer is here, r minus L plus 1. So that is the size of this particular window. So that is the score. So on right pointer, what we have to do? So maybe we are carrying a count variables to not to calculate these things every time. When we are consuming an element, we are increasing our count, and our running sum is also going to be add to nums of r for sure, the nums of r for sure. And tell me guys, so after consuming this, so from this particular point, you basically want to find which particular first L, if this particular things is land to that particular L, after that my window is going to be valid. So maybe the window that we are highlighting from A to D is invalid, but the window of BCD is start valid, right? Start valid. How? So what is the conditions of valid? Our score should be less than k. Our score should be less than k. So after throwing some elements, how we can throw some elements to our current window size? By moving our left pointer. If we are land to that particular index, so this particular left and most of its onwards, starting from this to all of its left are invalid, and starting from here to all of its right, till my right, all are valid. So B is valid, C is valid, D is valid, all are valid. All of its sum into length is bound to less than k. So when we are moving our right pointer, we are basically increasing our score. So if at any particular of time we will check while what is the score on that times is, can I say my running sum into count, if I am going to increase my count and running sum on by moving our right pointer? Yes, I can say like this way. If it is greater than or equals to k, so that means we are my left to right window which we are currently considering is invalid. So we have to move our left pointer at certain points. So our left pointer, so on this example, our left pointer is standing at this A index, which is invalid. By moving it to B, it is start valid. So all of its right are valid. So can I say if my running sum into count is greater than equals to my k, then we have to shrink our window. And how we can shrink our window? By what we have done here. We have to do exact reverse. So we have increased our running sum now by taking some nums of r. So we have to decrease our running sum by doing nums of L to minus L, and we increase our counter also. So we also have to decrease our count to minus equals to 1. And what else? And we have to move our left pointer to plus. So after the executions of this for loop, this L points to an index, where considering that left to right, all windows are valid. So then what is the contributions then? What is the contributions to my answer? Is nothing but where my right pointer minus left pointer plus 1. So all the elements within this boundary are all valid, and finally we can return our answer. Yes guys, the problem is as simple as that. I personally don't feel it is a hard problem. It is very standard sliding window things, and it's on interview it definitely tagged as a medium problem. It's not a hard problem at all. Yeah, now we can quickly go to the code iteration. So here you can see I have started into len of nums, answer to be 0, L count and running sum to all of 0, and I am moving my right pointer to till n. And when we are moving our right pointer, by right pointer we are consuming. So right pointer is a consumer. So increase your running sum to nums of r. Your count is also going to be increased, and at any particular points, if your running sum into count is more than your k, then move your left pointer. You have to shrink. You have to shrink. So right pointer is expanding, and left pointer, when you are out of count, like your left and right is a point of invalidity. It is like on that times you have to shrink your window. You have to shrink your window. How you can shrink? By moving your left pointer. So before moving your left pointer, what you have done with your right, you have to do exact reverse. So you have increased count, we have decreased count, we have increased running sum, we have negate out nums of L, we have add-ons nums of R, we have negate out nums of L, and we are moving our left pointer to make our window more shrink by moving our left pointer. And when this entire for loops is internal for loops is going to be executed, my left pointer is pointing to the first valid index, considering that to all of its till of all of the index to its right are valid. To all of its index to till right are valid. So I can easily add to R minus L plus 1 to all the elements to that particular block are going to be valid. And I am adding to that answer and finally returning the answer. Yes guys, the problem is as simple as that. And now we can quickly discuss the time complexity. If you guys are following us to the last sliding window playlist, you guys can predict your slide time complexity on your own. The time complexity is nothing but big of 2n for sure, because every element is going to be visited twice at max, once by right pointer, once by left pointer. Yes, definitely. And on space perspective, do you guys see we are using any extra space? Nope. All are variables. We are playing our entire games only with variables only. Yes, so the space complexity is big of 1. Yes guys, so this is the most optimal time and space complexity for this particular problems that I am able to come up, and I am definitely sure this is the most optimal time and space complexity can be achievable for this particular solution. And yeah, my submissions is almost like 93 to 95% faster than all the Leetcode submissions. So it is the most optimal time and space complexity that you can achieve for this particular problem. And if you guys are able to understand till this point, so I guess you guys are already doing, so please do subscribe to our channel, and please share the videos to your friend circles who are also preparing for top product in this company and also brushing up their DSL skills. And please turn on the notification so that when we are going to be live to our next video, you will get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.